Good day, everyone. Welcome back to our circular motion class. Let us try and see if we can solve the question on the board. We have a car of mass 100 kilogram, which is moving in a circle of radius. It's a circle of radius 20 meters. The car covers an arc distance of 5 meters. So a circle of radius 20 meters. The car covers an arc distance of 5 meters in a time of 4 seconds. Before I move on to solve the question, let me just draw a quick diagram. So I have a radius, I have an arc distance. So S is equal to 5 meters. I have my radius out to be 20 meters. And then I have a time of 4 seconds. So this is the information that I have from the question. A, we have to calculate the angular displacement. The angular displacement is our theta, and we already know that theta is equal to, or S is equal to R multiplying theta. Therefore, theta is equal to S over R. So this is going to give us 5 all over 20. 5 over 20 is 1 over 4, which is 0.25 meters. That is what we will have for our first question. Okay, so for our next question, we have to calculate the angular velocity. So B, the angular velocity omega is theta all over t. So omega becomes equal to 0.25 all over the time. The time is still 4 seconds. So omega becomes equal to 25 times 10 to the power negative 2 over 4. This is equal to 6.25 times 10 to the power negative 2. So in the end, you are going to arrive at 0.0625, or let us just leave our omega this way. The answer is radians per second. That is the answer for omega. Then the C aspect, we have to calculate the period of motion. Now the period of motion T has a relation with omega, but we know that omega is equal to 2 pi all over t. So t becomes equal to 2 pi all over omega. So you are going to get 2 pi all over 6.25 times 10 to the power negative 2. This is going to give us, so if I have 2 pi dividing our answer, then we should be arriving at 32 pi, which is also equal to 100.53. And since this is period, the unit for period is the second. Okay, then the D aspect of the question, we have to calculate the frequency. Frequency is 1 over t. So it's 1 over 100.53. This is equal to, so 1 divided by our answer, we are getting 9.95 times 10 to the power negative 3, and it is per second, or the hertz, which is equal to 8 z. So the unit is per second or the hertz. We'll quickly move on to the last aspect of the question, which is E. We have to calculate the force. So F is equal to m omega squared r, m omega squared r, or m v squared r. So our force becomes equal to, the mass is 100 multiplying omega. I think we have calculated omega already to be 6.25 times 10 to the negative 2 all squared, multiplying our radius. Our radius is 20 meters. So the force is going to give us, so I have 6.25 exponent negative 2 all squared, multiplying 100, and then multiplying 20. So this is going to give me 7.84 Newton. So this is what we will arrive at as far as our force is concerned. So you can also try this at home. If you find any difficulty or problem, you can quickly give a comment below, and subscribe to our channel, please, so that you can follow us and make corrections, additions, and subtraction to what we are doing here. Thank you very much. We'll quickly move on to the next thing. All right, thank you. Welcome back. We are going to move on to skidding. Skidding. Now, how do you define skidding? Skidding is simply a phenomenon which occurs when a body is supposed to move on a curved path suddenly takes a straight path away from the center of the curved path. So a quick example is, let's say you have a cyclist moving along a curved path this way. So the cyclist is moving in this track. You know the track is always circular, but sometimes instead of bending a curve, there is a mistake due to whether the cyclist movement or the cycle that the person is using or the car. It could also be a car and the person moves off the track. This is what we call skidding. Okay, so we are going to be using the simple pendulum to help calculate certain angles theta at which objects or cyclists or particles that are moving in a curve can move as far as their velocity is concerned, and the radius and then the gravity. So here we are going to derive an equation between the angle, the velocity of movement, the radius, and then what? Gravity. So quickly, let us consider a simple pendulum. So this is a simple pendulum, theta here. Good. Then you bring the pendulum to a certain angle, and then so let's say you bring the pendulum to a certain angle, and the pendulum is supposed to move in a cyclic form. So it's moving in a horizontal cyclic form. So if I want to draw it this way, then this becomes the cyclic form with which the pendulum is moving. So from here, we can say that this is our angle theta. Then there is by all means going to be a tension within the string. This is our tension T. Okay. Then also, this is the bulb. The bulb will have a weight. So the weight of the bulb is equal to mg. That is mass times what? Gravity. Now, since there is tension in the string, we can resolve the tension to get both the horizontal and vertical aspect of the tension. So this counts here, this counts here. So here we have T cos of theta, and then here we have T sine of theta. So this is both the horizontal and then the vertical aspect. We can also bring the vertical aspect of the tension here. So this becomes T cos what? Theta. So I have T cos theta and I have mg. And since the object is moving in a circular form, the object will have a centripetal force F of C, which is equal to mv squared all over what? R. So from the diagram, please look at the diagram carefully. Also, we can also say that, you see, from here to here is the radius of a circle. So from here to here is the radius R. And then since this is a string, there is going to be a distance or the length of the string L. Okay, so we can have an equation sine of theta is equal to R all over L. Let me call this equation 1. Okay, then we have already learned or studied that sum of upward forces equals sum of downward forces. Then the forces on the left is equal to the forces on the right here. So from the diagram, we can say that mg is also equal to T cos theta, equation 2. And then also we can say that mv squared over R is equal to T sine theta, which is our equation 3. So from the diagram, we have equation 1, which is sine theta is equal to R over L. We have equation 2, which is mg is equal to T cos theta. We have equation 3, which is mv squared of R is equal to T sine of theta. So these are the 3 equations that we can derive from the diagram. We are going to use these 3 equations to derive our equation or our relation between theta, V, R, and then J, as indicated in the above diagram. All right, so now we have our 3 equations. So let us see what we can do to our 3 equations. First, we have mg is equal to T cos theta. That's our equation 2. Then we have mv squared over R is equal to T sine theta. This is our equation 3. So we are going to use equation 3 and equation 2 to help us derive the equation that we want. So let's divide equation 3 by equation 2. So we are going to get mv squared over R divided by mg is equal to T sine theta all over T cos what? Theta. Okay. Now this and this will go away. then we'll have sine theta over cos theta. So I'm bringing this first, is equal to mv squared over r divided by, so times 1 over mj. So this and this will go away. We all know that sine theta is equal to sine theta over cos theta is equal to tan theta. So this gives us tan theta to be equal to v squared all over rj. So this is the relation between theta, v, and then rj, where our v is called the maximum. V is the maximum tangential velocity. V is the maximum tangential velocity. R is the radius of the circle. And then J is acceleration due to gravity. J is acceleration due to gravity. Okay, so we can just try a few questions on that. But one thing that we should note is that from that expression here, okay, the bulb moves along a straight path away from the center of the horizontal in times of skidding. Okay, so for skidding to take place, then it means that this equation here must be disobeyed. Okay, so for the bulb to stay in a straight and swing in a circle without skidding, the conditions tan theta is equal to v squared over rg must be what? Obeyed. So that when the tangential velocity v is large, then theta must also increase accordingly to avoid what? Skidding. So when this is large, this must also increase to avoid what? Skidding. Okay, so this is the basic principle for driving a cyclist or driving anything that is moving in a curved path. This is the basic principle that you apply so that you avoid what? Skidding. Thank you very much. I would like us to solve a question on this. This is a very simple question. Let's move on to it. Okay, let's take a good look at the question on the board. We have a conical pendulum of mass 2.0 kilogram and describe the horizontal circle of radius 0.5 meters. If the pendulum moves with a constant speed of 2 meters per second, calculate. First thing, for me, I would like to just draw a diagram. So I have a mass of 2.0 kilogram. I have a radius of 0.5 meters and I have a speed v of 2 meters per second. Let me quickly draw my diagram so we know what is going on here. Now, in our diagram, this is our angle theta. This is mv squared over r. This is mj or t. Let's say this is t cos of theta. This is t sine of theta. And then this is mg. Okay. And we have already learned from our previous derivation that mg is equal to t cos theta. Let me just put this in a bracket. And then we also know after deriving an equation, we have tan theta to be equal to v squared all over rg. Okay, so we can use these two equations to solve the question that we want to solve. The first one, we have to solve for the angle of inclination. We have to solve for the angle of inclination. So for A, we have to solve the angle of inclination A. Tan theta is equal to v squared over rg. So you have your v is 2, so you have 2 squared all over r. The radius is 0.5 and then g is 10. So you have 4 all over 5. So tan theta is equal to 4 over 5. So theta is equal to tan inverse of 4 over 5. If we use our calculator to solve for tan inverse of 4 over 5, we are going to arrive at 38.7 degrees. We are going to arrive at 38.7 degrees for our angle theta. Then the B side of the question, we have to calculate our tension. So from the diagram, mj is equal to t cos theta. Therefore, the tension T is mg all over cos of what? Theta. M, the mass is 2. So you have 2 times 10 all over cos of 38.7. This is 20 all over. So cos of 38.7 is going to give you 0.78009. Therefore, our tension T becomes equal to 20 divided by that answer, which will give you 25 25.6 Newton. 25.6 Newton. Please, it is not easy as it seems. You would have to do a lot of practice and go through the videos once again. Thank you very much. Leave your comments, subscribe to my channel, share with your friends and colleagues and students in school so that we can enjoy and move on. I am really interested in comments and also assessment of the video and what we can do to make things better. Thank you very much and enjoy the class. Bye-bye.